How's DevConf going? Ah, good. So, let's kick off here. So 6 years ago, on my first week at Yuppiechef, my first Tuesday at Yuppiechef, I broke the warehouse. So before we get started and jump right into things, hands up if you know Yuppiechef. Cool. Hands up if you've bought something from Yuppiechef. Hands up if you know Yuppiechef builds all of its tech in-house in a functional Lisp on the JVM. That one's a little harder than, there's one guy back there, two guys. A little harder than the other ones. Okay, so for those that haven't heard, Yuppiechef was founded from a lounge in Plumstead all the way back in 2006. Back when the idea of e-commerce was about as reliable as the load shedding schedule. Just look at those laptops, those LAN cables. It was a different era. And it really reminds you of how far we've come, how easy tech is these days. You had to work hard. I mean, those things were like 5 kilos. Looking back at the first version of the website, I don't blame people for being skeptical. If you saw this today, it's 100% a scam. Like, they're stealing your money, for sure. But founded by Andrew and Shane in a Plumstead lounge, Yuppiechef's now grown into a national presence with 21 stores, delivering millions of orders and handwriting hundreds of thousands of cards. While the business journey deserves a talk of its own, the technical story takes us even further back. The year's 2001, we had a different kind of odyssey on our hands. Back when ASP ruled the land and single-page apps were still science fiction, we were making technical decisions that were going to shape Yuppiechef's future for the next 25 years. Back then, out-of-the-box e-commerce solutions simply did not exist. The decision was made early on. We were going to be building in-house, building our own systems from the ground up. And this commitment to in-house development would become a defining characteristic of Yuppiechef, shaping not just our technology, but our entire approach to problem solving. In fact, that's the thing that drew me to them back in 2019. So where do I slot in? The name's Rob. I'm an adventurer at heart and a programmer by necessity. If I could manage it, I'd rather be on top of a mountain or deep in a cave. Little did I know that joining Yuppiechef in 2019 would be the start of one of my biggest adventures yet. Just enough time to hit my stride, and then bang, COVID lockdown, which was a particularly weird time in e-commerce. Our sprints became these bizarro late-night sessions, waiting for Uncle Cyril to call us for the family meeting, just to tell us what we could and couldn't sell the next day. One day it's essential goods, whatever that means. The next day, it's alcohol only on Fridays? But what does that mean for an e-commerce company? Are you delivering it on Friday? Are you buying it on Friday? It was changing faster than we could think. But here's the thing. We could still change our systems to adapt. Overnight, literally, we were retrofitting a system that had been built over 20 years, and we were doing it with confidence. Not because we were particularly brilliant developers, although we had some of those, but because we had managed to build something that was actually changeable. The kind of agility didn't happen by accident. It came from having a very specific and high priority value on simplicity, and a team that really believed in that value above all else. When the world turned upside down, instead of fighting with our tools, we were using them to solve real problems. And the ability to change course wasn't about individual skill. It was about having built a ship that could actually turn. So, onto the warehouse problem. Let's take some step backs to where it all began. For a good while, this was the extent of the warehouse. It was one shelf. We were effectively drop shipping our orders. So the order would be placed, and you would print out that order sheet, put it on a table somewhere, order the stock from your supplier, wait a couple weeks, and then maybe the stock arrives, and then send it out the door. This was not next day delivery, maybe next month. And if then, you're lucky. And it's not a great warehouse. As you can see, it really was just an overflow space. Sometimes you order a little too much, you have some popular products, you can now ship them out faster. But there was an idea there. But let's step away from that for a moment. The technical side started in PHP by modeling the financial elements of the transactions happening. You're placing orders, you need them to go through various statuses, you need to deliver the orders. That's as far as we had for technical backing. It was a lot of manual process. And PHP was the cool kid on the block. So we took it and we built in it. The backend really was simple to begin with, but skip forward a little while, and the neighbors moved out. We need to hold a bit more stock. So we move in, we knock down some walls, and we put up some more shelves. And all of a sudden, we start having this technical problem of how do we manage a stock-based business, and how do we scale it? Picking items for orders, turns out, is actually a really hard problem to solve when you want to solve it in a scalable and practical way. To understand why this was such a challenge, we really need to remember the times we were living in back then. E-commerce was just not figured out. Take-A-Lot didn't exist. Who here remembers Kalahari.net? I have these such vivid memories of growing up and waiting weeks and weeks for my new PlayStation game to arrive at the gate. And it was the highlight of my month. And it's such a different experience today. Today, if you're not getting it tomorrow, you almost don't want it. Now, deliveries are so ingrained in our lives that we barely think of what it was like before them. Little did we know, but we had a serious mountain in front of us. We had upgraded from our single shelf. We now had these new shelves to fill and stock that was starting to fill them, but no real idea of how to manage it. Orders were growing exponentially, and our manual picking process just could not keep up. Warehouse staff were spending ages walking between aisles, hunting for items that could be anywhere. A single wedding registry could take half the day to fulfill. We had a problem on our hands, and it was time to make decisions. How could we manage this warehouse? How could we make picking even marginally easier? And we tried some creative solutions. One of the more interesting ones was you take the whole warehouse and you just line it up alphabetically. All the A's over there, all the Z's over there. And then when you have an order that only wants one item, you put it in the relevant aisle and hey presto, you can pick marginally faster. It worked, sort of, but we were still spending way too much time walking around. The improvements were marginal at best. And then there was the internet. Back in 2011, the internet was even less reliable than electricity. And that's saying something. Man, load shedding's been around since 2007. We needed a system that could keep the warehouse running even when the internet was down. And again, that meant building something that lived entirely on our own hardware and with our own software. Something that could operate completely offline. Humans searching the warehouse was no longer good enough. We needed a system that could search the warehouse for us. It was decision time. It's 2011, and we're a big boy company now. And what do big boy companies use to build their software? Any guesses? Oh, what kind of Java though? Enterprise Java. Yes, Java EE, the favorite tool of many an avid entrepreneur. Who here is using Java EE? Oh, shame. I guess everyone has to go through that particular rite of passage at some point in their careers. Well, we went all in. Java EE, because of course we did. And what's Java EE without a Swing UI front end? And while we're at it, throw in some JBus, throw in some Firefly. The obvious choices. 6 months, countless design meetings, endless architectural discussions. And what did we have to show for it? Not very much. In a space where you don't know what you don't know, it's really hard to build a system that suits every problem you're going to encounter. There's a reason why SAP and its ilk can cost millions. They're modern-day marvels of complexity, built on decades, maybe even centuries of expertise. Around this time, a certain Rich Hickey gave a talk that would change everything. Simple, made easy. A talk I would highly recommend as required watching for a developer of any background. But a few pearls that stuck with us from that talk were: developers know the benefit of everything, but the trade-off of nothing. It's in our nature to think additively. When we're faced with a problem, our thought process and our first instinct is to add a solution. A new feature, a new layer, a new abstraction. It's so much harder for our brains to think subtractively, to consider what we might remove from the problem space. And so our mindset has been trained as, what does this bring to the table, rather than the more nuanced, how is my problem best solved? ORMs are OMG complexity. When most of us learned to program, we were handed this hammer called object orientation. And like any good hammer, it's great at hitting nails. But somewhere along the way, we forgot that not everything is a nail. We started building entire frameworks to make everything look like a nail, just so we could keep using our favorite hammer. And somewhere along the line, we stopped counting the cost of this complexity that we were taking for granted. Simplicity is prerequisite for reliability, by everybody's favorite Dijkstra. And that's when it clicked. Every time we built a class hierarchy or mutated data in place, we were spending this complexity budget. We were making our software less reliable inherently. And when that budget ran out, the debt collectors come knocking. We've all been there. That moment when you realize your beautiful abstraction has become a liability. The very thing that was supposed to make your code more maintainable has now locked it in place. It's become a straitjacket, tied down. So where to from here? Well, as it happens, that Rich Hickey had been thinking about these problems. He'd recently released a new language called Clojure, built on the JVM, but with a radically different approach to simplicity. And just to give you guys a bit of a taste as to how different this approach was, let's look at the code lifecycle of a few open source programming languages. Rust. Everybody loves Rust, right? Now this graph shows us lines of code introduced over time. And as you can see, that program that you wrote in 2015, if you compile it today, only about 7% of the same underlying code is creating your end application. Let's take a look at Node. And in the same example again, just as bad. That program you wrote in 2015 now only has about 8% of the same code today. And enter Clojure, a code base so solid in principles that it doesn't get recycled every few years. It's actually quite jarring when you line it up against the status quo of today. That same program in 2015 shares 90+% of the underlying code today. So we decided to do a bit of an experiment. How about we take our Java EE Swing UI JBoss festival and rebuild it in Clojure? Any guesses as to how long that took? 6 months of work? 2 weeks, nice. 2 weeks. Just let that sink in. What on earth were we doing? 6 months of meetings, architecture, and complexity replaced by 2 weeks of actual building. Just how? Why? What were we even beginning to try with our enterprise? And let's break it down. How did we achieve in 2 weeks what had taken 6 months? And more importantly, what did this tell us about the role simplicity was playing, and what precisely were we trading it off with? The answer, as it turns out, lies in something we all deal with every day: our finite brain space. Who here can hold an infinite number of ideas in their head? No one? Good. Unfortunately, we're in a world where there's this constant domination of new ideas, where whatever the latest fad is the thing you need to think about, the thing you need to learn, and we've forgotten to become experts in the things we already know. As much as CPUs haven't really kept up with Moore's law, our brains have been dealt an even worse hand. Instead of getting better and better, if anything, we're getting worse at keeping our focus. We, as developers, are constantly fighting this battle of how much we can keep in our heads at once. Whether it's business logic, quirks of the system, or how many emails we desperately need to reply to, but just can't find the time for. Complexity is the most valuable currency we use in our day-to-day jobs. And where we spend that currency, I feel like we've stopped paying attention to as a community. Let's break it down. In the world of creating software, you're constantly juggling many concerns. So for argument's sake, what if we use 20% of our brain space going into understanding our business logic? Maybe 30% gets consumed by being an expert in your language and its quirks. And maybe another 30% is taken up by understanding your existing implementation, your legacy, and all the quirks of that. That's 80% of your mental capacity gone before you even begin to create a feature. 20% isn't exactly leaving you much room to work with. Add in urgent feature requests, meetings about missed deadlines, and suddenly you've got a recipe to achieve nothing at all. This isn't why any of us fell in love with programming. This is a nightmare. So how do we go about unwinding this knot? Instead of thinking about more, what if we think about less? Let's take a closer look at that 30% chunk we're spending on language knowledge. Does this language we use really need to take up that much of our brain space? The Clojure approach, and the way I like to think of it, isn't that it's very new. In fact, it's a very old way of working. It asks a seemingly simple question of what is the minimal set of tools I need to do my job? And can we become experts in those tools? Mutable data by default. Do we need that? Not really. It doesn't inherently give us something that we can't get away leaving it immutable. Endlessly extendable types that are binding complexity into every corner of your application? Well, we could just treat data as data and leave it at that. In fact, just have a few basic types and some collection types and let them all interact with all of your core functions and keep it sensible. First class functions? Well, yeah, passing functions around and composing them is a lot easier to reason about than class hierarchies and polymorphism. And speaking of class hierarchies, they have their place, but when you're jumping into that problem space where you don't know what you don't know, modeling is a bit of a fool's errand. Make no mistake, Clojure was not the easiest language to pick up. In fact, it's probably one of the most difficult, precisely because of what makes it simple. Each tool in Clojure does one thing, and does it well. That's the most simple and flexible way to build your software. You have a tool that serves a specific job. As soon as you start to complex and interweave ideas into your tools, you run into a problem. Think about Ruby for a moment, and especially with Rails. You can make a Ruby application serve web requests in 5 minutes. But good luck changing paradigms in a 20-year-old Ruby application. Magic, by its very nature, is unreasonable and complex. When you're dealing with complex tools over time, that complexity compounds, and you have to serve the compound interest in whatever way you can. But if you're willing to take a slow start and learn an environment with simple tools, you can build up from first principles. You can create an environment that is suited to your needs and is as flexible as you want. The side effect of this approach is that you develop a deep understanding of what's actually happening, with very little of the language semantics getting in the way. It's not a popular approach, and I think it's precisely because it's so hard to get started with. In a world where we're constantly trying to lower the entry bar for all of our technologies, whether through AI or tutorials, we've kind of lost this idea of craftsmanship, where there's a true honor in creating something that's greater than the sum of its parts, and an elegance and a design. But alas, hubris is a cruel mistress. So there we were, going about our day jobs, using this new Clojure tool, and feeling pretty chuffed about ourselves. Everything seemed so easy. And fortunately, it's a very pragmatic language. Instead of having to kickstart its own ecosystem of problems to solve, it was built on the JVM. Great. If there's already a tool built in Java, we don't need to be precious about it. Some mild interrupt and you can use your Java library. But, and a really big but, we were yet to experience the other side of using sharp tools for the first time. A teeny little bug had been left in some production code that was allocating the stock to those orders going out the warehouse. And it didn't quite account for negative ordered quantities. So one day, someone decides to return an espresso machine that they don't want, and we get a little -1 in there. Our shiny new warehousing system goes, "Ha! How dare you return something to me? I'll show you," and proceeded to take every last Nespresso machine we had, 46 of them, and shipped it straight back to that customer. How do you like them beans? In the ultimate act of passive-aggressive warehousing, some very confused packers, and we had the world's most caffeinated customer on our hands. Thankfully, mistakes easily made were easily fixed. And this one had only had an effect on that single customer. Chaos warehousing. By the time I joined Yuppiechef, this warehousing system had matured quite dramatically. We'd settled on chaos warehousing, in which everything was everywhere, but which has the curious side effect of making it really easy to find what you're looking for. If you need to fetch the red kettle off the shelf, and you walk to the aisle only to find a wall of all colors of kettles, it takes quite a long time to pick out the right one. But turn your warehouse into an absolute mess of products everywhere, and the system tells you to go to a certain spot. Well, there's likely only one kettle there. Hey presto, you're now finding items a lot faster than you used to be. Picking by aisle was another strategy. We had run into this quirk where if you needed to find a kettle on one side of the warehouse and a knife on the other side of the warehouse, you rack up a lot of steps really quickly. As happy as Discovery Health was with our warehousing strategy, it made for some really slow processes. So instead of saying, hey, you need to go and pick for this particular order, we changed it to saying, well, how about you pick all items needed for any order in this aisle and then go drop those off, and we'll sort them out into orders later. And so piece by piece, this problem space had crystallized. What was once an unknown was becoming known, but the flexibility and the speed of iteration that we'd grown used to hadn't slowed down. And in fact, had sped up dramatically. Broad sweeping changes weren't so scary when you could reason about what the system was doing. And that was particularly impressive when you consider it's a distributed system with hundreds of people interacting with it at any one time. Well, as things were going, it wasn't all whisks and wine glasses. There's something bizarre that happens in human psychology. When you offer something for free, no matter the value, people won't bat an eyelid. For some reason in our brains, free has become a synonym for a scam. But if you offer that exact same value for a small fee, people will go ballistic. It was February 29th, 2024, Leap Day, and the marketing department had had a great idea. That idea was we could get a KitchenAid mixer and give it away for 29 Rand. How cute is that? The only problem being how that offer came about. Without the dev team's knowledge, it was going to be given out as a voucher right on the front page of the website. Important editor's note, the voucher system had never been designed with concurrency in mind. So there we are, enjoying our Leap Day, minding our own business, and out of nowhere, all the CPUs are spiking. Everything is skyrocketing. It is battle stations. Nobody knows what's going on. We think we're getting DDoSed. And until a very sheepish voice comes over from the marketing department and lets us know of the monster that's been unleashed. And so we had our problem. Over 1,000 people competing for a single voucher, the website hanging on for its dear life, and when you attempt to check out, the system would check to see that nobody else has that voucher in their cart. Because naturally, you don't want multiple people sharing the same voucher and using it twice. We had our very own human race condition. as I saw it, we had two options. One, do nothing. Not really an option. People were already getting incredibly mad that they weren't getting their 29 Rand of KitchenAid mixer. The site was wavering, social media was on fire, and there had to be something else. We could remove that concurrency check for the briefest possible moment. And now, I wouldn't be telling the story if we did that and everything went perfectly. But we did do that, and in the same 10th of a second, according to the timestamps, not one, not two, but 3 KitchenAid mixers got out for 29 Rand. And unfortunate as it was, having a slightly more expensive marketing campaign than we wanted, we got out to the other side. But it was really another moment in my career that reinforced our needs for simplicity. The voucher system was and is complex, and when something really unexpected happens, it became difficult to act confidently. And that's exactly why we need tools that can help us understand and modify our systems quickly. Tools that let us see what's happening in real time inside of our application so that we can make changes with confidence and understand the impact of those changes immediately. The keys to a big part of this broad-scale simplicity is a tool dubbed the REPL, or read-eval print loop, if you like. Now, many of you know a REPL, but let me introduce you to the sharpest tool in the Clojure toolbox. In essence, think of it as the matrix. It's an application that can jack into a running Clojure program, and not only does it have access to any symbols in your running application, it can ad hoc overwrite any of those, changing and developing the application while it runs. Now, at this point, I hope the hackles in the back of your neck are standing at full alert, because this is a nightmare. But let's see if we can convince you for a moment to suspend your disbelief and run with me. This approach built some pretty cool stuff. In a landscape where simplicity rules, and it's only functions as far as the eye can see, all of a sudden it becomes really easy and reasonable to make considered changes to a running Clojure program. Once you can understand and trust your running program, your world kind of opens up. Have a bug occurring in production, but no idea how to replicate it? REPL in some logging and Bob's your uncle. A critical bug has crept into production, crashing a particular flow, but the error is obvious. Well, you don't have to wait for a full compile, deploy, run cycle. Just REPL in the change. Need to experiment with some data to figure out just what shape it's in? Great, REPL and have at it. Now, this is definitely on the cowboy end of the spectrum, but these same facilities are available to your development environment. And enter REPL-driven development. We all know about test-driven development. It's become a cornerstone of modern software development. But I'd like to suggest that we've lost something in the pursuit of test coverage. We've become so focused on security and validation that we've forgotten how to trust. Think about it. When was the last time you wrote code without immediately thinking about how you're testing it? Or even thinking about how you're testing it before you've written your code? We've grown so used to the rug being ripped out from under us that we crave the security of those green check marks. But as anyone who's really followed test-driven development will tell you, you won't think of everything. There will always be gaps. And in a certain way, it's almost become fear-driven development. We're so afraid of what our application might do that we build skyscrapers surrounded by load-bearing scaffolding. We add layer upon layer of tests, trying to catch every possible edge case. But here's the thing. No builder in the world tests every brick before they lay it. They use their experience and judgment to know when to verify and when to trust. Is this wall straight? Is that wall load-bearing? They test the things that matter, not every single component. So what if we took a different approach? What if instead of writing tests first, we wrote code in smaller, more focused pieces? Code that exists in its own capacity, is easy to reason about, and does exactly what it says on the tin. In essence, let's learn to trust what we write again, instead of trying to find a surrogate to trust. This is where the REPL comes in. It's like having a conversation with your code, and not in that weird AI way that's become so popular. You can try things out, see what happens, and build your understanding piece by piece. And it's not about writing perfect code first time. It's about exploring the problem space, playing with your solutions, finding the quirks, and growing to understand it inside of your running application. And when you understand your code more deeply, you don't need as many tests. You've built trust through that exploration and understanding. You know that what your code does because you've seen it and felt it work, not because you've written tests for every possible scenario. This isn't to say we should abandon testing entirely, far from it, but maybe we should think about it slightly differently. Maybe we should focus on understanding our code first, and then add tests where they matter most. Circling back, it's these very approaches that I bumped into on that first Tuesday when I broke the warehouse. What at the time felt like a career-altering mistake was barely a blip on the radar. Within a few minutes, my colleague had REPLed into the production environment, understood what data was clogging the pipe, saw where exactly it was, and then unblocked it, hardly batting an eye. Yuppiechef has been incredibly lucky. We existed in a time and a place where the world was ready to explore e-commerce for the first time. And we were given free rein to make mistakes and ample time to iterate through failed approaches. We could play and discover in a way that was always going to be transient. 10 points to anyone who noticed that Gordon Ramsay's misspelled there. Today, e-commerce is a different beast altogether. Starting something by yourself is close to impossible, especially if you were to be crazy enough to build everything in-house. But hopefully, if this talk leaves you with anything, it's this. Be on the lookout for when the world is ready for a new paradigm. And if you can, take on that new paradigm and take simple tools. Looking back at where we began, a warehouse in chaos, a team struggling with the complexity of this new beast, and a system that was becoming harder and harder to maintain by the day, we could have thrown more stuff at the problem. More frameworks, more abstractions, more tests, but instead, we took a step back and we asked ourselves, could we do with less? The answer led us to Clojure, to the REPL, to a different way of thinking about software development. It led us to a system that could be understood, modified, and trusted. A system that could handle the unexpected, like a global pandemic, with grace and flexibility. And the beauty of this approach wasn't about the code we would write. It was about the space it could create, and space to think and to understand, to solve real problems. When you're not fighting with your tools, when you're not drowning in complexity, you can focus on what matters, building software that works, that's maintainable, and that you can trust. So the next time you're faced with a complex problem, remember the warehouse. Remember that sometimes the best solution isn't to add more, but to understand what you already have. Remember that the right tools, used well, can transform not just your code, but your entire approach to software development. Thank you very much.